Student, today I are going to discuss some examples on graphical method. So first example is minimize z is equal to 3x1 plus 2x2 subject to 3x1 plus 2x2 subject to the constraints. Constraints are given 5x1 plus x2 which is greater equal 10. Okay, which is greater equal 10. Then next constraint is x1 plus x2 is greater equal 6, and next is x1 plus 4x2 is greater equal 12. Okay, and non-negative condition. Okay, so here objective function is minimize type and all constraints are given that which is greater equal. So our regular method use graphical method. Firstly, to write all constraints in equality form. Okay, first we write all constraints inequality to equality, okay, that is 5x1 plus x2 equal to 10, x1 plus x2 equal to 6, and x1 plus 4x2 equal to 12. So find the points of each constraints. Points of each constraints are, for first line 5x1 plus x2 equal to 10. If x1 is equal to 0, then x2 equal to 10, and if x2 equal to 0, then x1 equal to 2. Therefore points are 0, 10 and 2, 0. Okay, this is a points. Then for second constraints, x1 plus x2 equal to 6. If x1 is equal to 0, then x2 is equal to 6. That is points are 6, 0, and when x2 equal to 0, then x1 is also equal to 6. Therefore points are 6, 0, 6. Okay, here 0, 6 and 6, 0, 0, 6 and 6, 0. So third constraint is x1 plus 4x2 equal to 12. x1 plus 4x2 equal to 12. So points are when x1 is equal to 0, then x2 equal to 3, and when x2 equal to 0, then x1 is equal to 12. So points are 0, 3 and 12, 0. Okay, so this is the points of our equations. So plotting a graph. Here constraints are very x2 points of x2 axis are lastly 10. Okay, and x1 axis are lastly 12. So plot a graph in this way. This is suppose x1 axis and this is x2 axis. Okay, here 0. So then points, take a point. Here 1, 2, 5, 6, 7, 8, 9. Here 10. Here something here. Suppose that here 12. Okay, here 11 and 12 in this way. So here portions are very less. Then 1, 2, 3, 4, 5, 6, 7 and 10. Okay, here -1, -2, -3 in this way, -1 up to so on. Okay, first point is 0, 10, 0, 10, and second point is 2, 0. Okay, So by using scale, so plot join these 2 points, joining these 2 points, suppose that in this way. Okay, this is a straight line, but here not a scale, so adjust this. Okay, so first this line is 5x1 plus x2 equal to 10. Okay, so second points are 0 6 and 60, 0 6 and 60. So join these 2 points. This is a line. Okay, this line is a x1 plus x2 equal to 6. Okay, then next constraint is x1 plus 4x2 is equal to 12. So their points are 0 3 and 0 3 and 12 0, 0 3 and 12 0. So join these 2 points. Okay, in this way. So this is a x1 plus 4x2 equal to 12. Okay, in this way. And so portion of feasible region is here, feasible region is unbounded region, because all constraints are greater or equal. So first constraint is 5x1 plus x2 is greater or equal 10. Greater or equal 10 means all region of this constraints are greater than this line, greater than and equal to this line. So all region are, this is a region of, means upper side of this line. Okay, then x2 plus x1 plus x2 is equal to is greater or equal to 6. Their portion is also in this way, upper side of line, and their portion is also, this is a portion of x1 plus 4x2 is greater or equal to 12, because their constraints are greater or equal to 12. Therefore the region is a must be upper side of their lines. Okay, and so common region, this is a common region, this is common region of this, all these are here 12, here not. Okay, and this is the region is a unbounded region. Okay, so points are, suppose this is A, this is B, this is C, and lastly here D. Okay, therefore the feasible region here, therefore the shaded region, is feasible region. And so objective function is here minimize type, therefore the minimum value at that point. So points are, the extreme points are A, B, C and D. Okay, so 4 points are here, this A, B, this C and this is D. Okay, points A are coordinates of point A is 0 10, and point D point is 12 0. Okay, so point B and point C are, point B and point C, here this point B and this point C. Okay, this is the intersection of two lines. This point B is intersection of these two lines, 5x1 plus x2 equal to 10 and x1 plus x2 is equal to 6. So using these two equations, find the coordinates of point B and similarly point C. Okay, so to find point B, to find coordinates of B. Okay, and Point B is a intersection of two lines. What two lines? Here two lines are 5x1 plus x2 equal to 10. 5x1 plus x2 equal to 10 and x1 plus x2 equal to 6. So subtracting this we get 4x1 equal to 4, which implies that x1 is equal to 1. Putting x1 is equal to 1, we get x2 is equal to also 5. Okay, and therefore point B is 1, 5. Similarly point C is intersection of two lines. x1 plus 4x2 equal to 12 and x1 plus x2 is equal to 6. Point C is intersection of two lines, and two lines are x1 plus 4x2 equal to 12 and x1 plus x2 equal to 6. So subtracting this we get 3x2 equal to 6, which implies that x2 equal to 6, and we get x1 is equal to x2 equal to 2. x2 is equal to 2, therefore x1 is equal to 4, and therefore point C is 4 and 2, and therefore to find value of Z, lastly to find value of Z, the objective function is minimize, and therefore here objective function is minimize Z is equal to 3x1 plus 2x2. Okay, and so find the value of minimum at point all this. Okay, at point 0, 10, the value of Z is 20. At point B point 15, the value is 3 plus 10, Z is equal to 30. Then at point C point is 42. Then value of Z is 12 plus 4, 16, and at point lastly 12 D point. Okay, value of Z is 36. Okay, and therefore their minimum value of Z in all points is this is a minimum Z. Okay, and therefore the value of objective function the minimum value of objective function at what point? At x1 is equal to 1 and x2 is equal to 5, its value is 30. Okay, this is our solution in this example. Okay, so in this way, similarly next example, suppose another example here. Next example first. Minimize Z is equal to minimize Z is equal to minus x1 2x2 minus x1 plus 2x2 subject to minus x1 plus 2x2 subject to minus x1 plus 3x2 minus x1 plus 3x2 is less equal 10, x1 plus x2 is less equal 6, and x1 minus x2 is less equal 2, where x1 x2 are greater equal 0. Okay, here objective function is minimized type, and here constraints are all less equal type. So we are direct use the points of this. Firstly, we write all constraints in equality point, inequality to equality, and then find points. Okay, let first minus x1 plus 3x2 minus x1 plus 3x2 equal to 10. Points are when x1 is equal to 0, then x2 is equal to 10 by 3, and x2 is equal to 0, then x1 is equal to minus 10. Okay, so here minus x1 plus 3x2 is equal to 10, x1 is equal to 0, then x2 is equal to 10 by 3, and then x2 is equal to 0, then x1 is equal to minus 10. Okay, so for second constraint, x1 plus x2 is equal to 6. Their points are already found in previous example. x1 is equal to 0, then x2 is equal to 6, and x2 is equal to 0, then x1 is equal to 6. So here points are 0, 6 and 6, 0. Third constraint is x1 minus x2 is less equal to, which implies that points are x1 is equal to 0, then x2 is equal to minus 2, and x2 is equal to 0, then x1 is equal to 2. So points are 0, minus 2 and 2, 0. Okay, so plotting a graph, we get plotting a graph in this way. Okay, here 1, 2, 3, 4, 5, and lastly here 6. Here 1, 2, 3, 4, 5, 6. In this way, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, minus 9, and minus 10. And below minus 1, minus 2, and in this way, this is x1 axis, this is x2 axis. So points are 10. Here first point is 0, 10 by 3, and minus 10, 0. Okay, so 0, 10 by 3, 0, 10 by 3 means 3.33 something. Okay, 3.33. Suppose that this is 3.33 here. Okay, and then next point is minus 10, 0, minus 10, 0. So join these 2 points. Joining these 2 points, this is this line is a minus x1 plus 3x2 equal to 10. This is this minus x1 plus 3x2 is equal to 10. Okay, then next is 6 and minus 6 and 6. Okay, so you extend this line, then there this is line, this is second line, x1 plus x2 is equal to 6. Okay, then next line is x1 minus x2 is equal to, their points are 0, minus 2, 0, minus 2, and 2, 0. So join this. This line is x1 minus x2 equal to 2. Okay, in this way. Here now to find the feasible region. Okay, so all constraints are less equal type, means their value, all constraints, their value are must be below below side of line. Okay, so below side of line is, this is a portion, okay, this, and all in here first is minus x1 plus 3x2 is must be less equal 10. Less equal 10 means this is this line is minus 3x1 plus 2x2, 3x2 is equal to 10. Their portion must be below the this line, below this line. Okay, then next is minus x1 plus x2 is less equal 6. Their portion is must be this portion below side of this line. Okay, x1 plus x2 is equal to 6 below side of this line, and their portion is a less than type means their portion is a x1 minus x2 is less equal to 2. Their portion is must be less than this side. Okay, in this way. So common region is here, common region is, this is a common region. Okay, here 0, this is a common region. All common regions are, this is 1 point, this is 1 point, this is 1 point. Their region is a must be, this is the common region. Okay, so and find this point. Suppose this is O, A, B, this is C, this is D. Okay, and then find all points of this. Find this B point. B point is the intersection of minus x1 plus 3x2 is equal to 10, and x1 plus x2 is equal to 10, x2 is equal to 6. So using these two equations, find x1 and x2 of this, means find B coordinates of B. Similarly, find coordinates of C. Okay, using these two equations, and we get and find the minimum value of all these points. Okay, find minimum value of all these points. We get our solution. Okay, in this way solve in previous steps. Okay.